Okay, so for this example, now we have decreased the friction a little bit. So in the previous one, we had a friction coefficient of 5. And now we're going to decrease that role of friction just slightly down to 4. And so we saw that when we had no friction, we had oscillations. When B was equal to 5, we had no oscillation. So what happens if we decrease this a little bit? So again, let's solve the characteristic equation associated to this system, which would be our r squared, and now B is equal to 4. So we have plus 4r plus 4 is 0. And here we have 1 repeated real root of minus 2. And so our general solution when we have 1 repeated real root would be C1 e to the minus 2t in this case, plus C2 times t e to the minus 2t. And then again, using our initial conditions, which are the same, x of 0 is 1, x prime of 0 is 0, we could come up with our, we could solve for these constants C1 and C2, and the solution to this initial value problem is that C1 is equal to 1 and C2 is equal to 2. So our solution over here looks pretty close to the solution that we had in the previous part, except we have a t in here. So now if we think what happens as t goes to infinity, well, that's going to go to 0 because of the negative up here. And as far as these two are concerned, this thing wants to go to 0, this thing wants to go to infinity, but the exponential function dominates this t over here. So this is going to go to 0 quicker than this thing wants to go to infinity. And so overall, as t goes to infinity, this is going to go to 0. But this added t in here changes things slightly. So let's see what that might look like in the solution. So if we were to graph this solution, that's what I have over here. We really can't see much of a difference between this and the previous damping case. We don't get any oscillations again. And here we have kind of 1 repeated real root. And this is slightly different from the previous terminology. We called the previous solution an overdamped solution. Here, this is what we're going to call critically damped. Okay, and what that means is that this amount of friction B is kind of like the least amount of friction that would still give us no oscillations. And so if I decrease B, if I decrease the friction any more, then the solutions to this characteristic equation we'll see are going to no longer be real, and that's going to change the behavior of our solutions. We're going to get some oscillations in our solutions. So this is kind of, this particular value of B for this system is the point where our solutions are still not going to oscillate, but if we change it just a little more, if we made B just slightly less, then suddenly our solutions are going to change quite drastically. So this is kind of the critical damping that we can put on the system, and if we put any less damping on the system, the dynamics are going to change. So that's what we'll take a look at in the next example.